Okay, dear students, so here is another problem in series of JEE Advance. So guys, this is the problem of simple harmonic motion. Okay, here is a rod which is massless rod. Okay, this is a massless rod. So a small bit of mass m0 is rigidly mounted on a massless rigid rod of length 3L from one end of the rod as shown. The rod is connected to two springs having spring constant K1 and K2. Initially, the rod is in horizontal position in equilibrium. Calculate the time period of the system for a small vertical oscillation. Assume that spring remains vertical during the motion. So let us continue with the solution of it. So first of all, we have to know what we have to find to reach at the solution level. So it has asked time period. So we know that time period is what? 2 pi m upon a effective. So m is what? M naught, and you need to find k effective. So our aim to calculate the k effective for this given question. Okay. So in such kind of problem, initially we have to give the displacement. So let us give the displacement in that direction. Let us say it is x. Okay. And also here is chances of rotation. So maybe when you displace it in downward direction, it will rotate like this about m naught. Suppose it is like theta. Angular displacement is theta and linear displacement in downward direction is x. Okay. So after a while, this graph will change like this. This is the initial position. When you apply force in downward direction, it will like this. It will like this. Okay. The rod will look like this. Like this. Okay. So when you displace it through x and angular displacement is theta, then the end position of rod has a displacement of x. This is L, so x plus L theta, and this is in upward direction x minus 2L theta. Okay, so this theta is very small, so definitely displacement will be in downward direction, but for the sake of simplicity I am indicating it in upward direction. So okay, so this is the expansion and compression of the spring, so that we can execute the spring force. What is the spring force acting on it? Okay, so let us see. So few tips I want to give you that bed is in unsymmetrical position. Unsymmetrical. So unsymmetrical position. So combined motion sustained. Combined motion in which there will be a translation plus rotation. Translation plus. Okay. So when you displace it, the restoring force is act like this. The restoring force, suppose F restore. Okay, and also torque about m naught will be 0. Okay, so torque about m naught will be 0 because massless rod. Because of massless rod. Okay. What you can write? You have to write like k1 into x plus l theta into l equal to k2 into x minus 2l theta into twice of. After cancelling it, we can write, we have a relation in k1 and k2 like this. L theta into k1 plus 4k2 equal to x into 2k2 minus 0. Okay. So let us say equation number. Now, dear students, we have to find f restoring, and this will be like minus of k effective into x. So we need to find k effective. So from the problem, we can write restoring would be minus of something k1 into x plus L theta, okay, plus k2 into x minus 2L. Okay, this is like this. So minus of k1 x plus k2 x we can write plus L theta into k1 minus 2. So from equation 1 we can write L theta equal to x into 2k2 minus k1 upon k1 plus 4k2. Okay, so put this value here. After calculating we will get a value like this. After putting this value and after solving we are getting 9k1 k2 upon 4k2 plus into x. So we are getting k effective here, that is 9k1 k2 upon k1 plus 4. Okay, so our aim is to calculate k effective. Right now we can write the expression for the time period of the question of the bed. Okay, so time period is given by 2 pi under root m naught by k. So after calculating and after putting the value of like this, m naught upon 9k1 k2 into k1 plus 4 of. After putting the value of 3 outside, because 9 is in under root 2 pi by 3 under root m naught into k1 plus 4 k upon k1 k2. This is the final answer. Okay guys, so this is the solution of this problem.